Ladies and gentlemen, please welcome the next speaker, Mr. Vipul Kocher, TestAIng, India. Big round of applause, ladies and gentlemen. Yeah.
Namaste. Salamat Datang. My name is Bond, James Bond. It's interesting. I'm happy to hear you laugh, by the way. I'm here not to talk, but I have a very special purpose. I was told that as testers, you guys are having a big problem sleeping in the night. So I'm a sleep therapist. I'm going to put you to sleep now. Let's see if I can get my presentation working. Can you please switch to my presentation? Or you are already? Yes. It's going to be a very technical talk, and I would like to know how many of you have a decent idea of what artificial intelligence is and how does it work. Please raise your hand if you have a good idea about what AI is. I need to know that. Without that, I cannot put you to sleep. Okay, a few. All right. So I would try to keep my presentation, although technical, but human understandable, not AI understandable. Otherwise, my talks are only understandable by AI. We are talking about trustworthy AI. So my questions, the questions that I'm going to answer, first of all, I'm going to ask those questions, and then I'm going to answer those questions, are related to whether you can trust AI or not. The only thing you can trust AI for right now is only for one thing, that it is going to take your job. Not a very happy statement, right? Yeah, this job taken, new jobs got in. I'm not actually into that. So we're not going to talk about whether AI is going to take your job or not, and how do you use AI in testing or in your daily life and so on. I'm going to talk about, can you trust AI? And trusting AI is very hard. Why? Let us take a look at this nice video. I don't have the source of the video, but I hope you enjoy it. I'm trying to see how I can get the sound going.
For a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah. I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
It doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter and jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out
A bit, that means like a lot.
A bit means a lot?
In my world.
All right. There we go.
Doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done.
All right, you get the idea. This is what AI today is. Instruct it very clearly, and then it will do the job, but you're not sure if your instructions are clear enough. Because for human beings, these instructions are clear enough, correct? But with AI, at times it becomes very difficult. This was the same with programs. This is the same with programs. When you write a program, you know explicitly that you have to give every single instruction. But with AI, because there is a word intelligence in artificial intelligence, we assume that it would work because we are telling it to work. So this is one big problem. And look at this cartoon, please. I will give you maybe 45 seconds to look at this cartoon. This is also reality today. Now, there are two types of AI. It's interesting how quickly the current version of AI, that is machine learning, sort of became technology of yesterday when generative AI, LLMs, or specifically ChatGPT exploded on the scene in 2022. So this is about code generation. And this is something that as developers, as testers, we are very fearful of, because it starts with AI writing a bit of code, not working correctly, everybody laughing at that, oh, AI is so bad. But AI is improved bit by bit, and then it starts to write 5% of the code, 10% of the code, 50% of the code, right? It doesn't understand you at this point of time. It makes mistakes, and we all think that that's how it is going to be. No, things are going to improve. Whether they are going to improve with LLMs, ChatGPT kind of style of things, or they are going to improve with new technologies, that's a separate debate, separate issue. We'll not talk about that. But things, AI will improve, that's for sure. But today, this is where we are, and it is today's problem that we have to solve. Can we trust this kind of an AI? Maybe last bit of humor today. How many of you have watched The Terminator? If not, anybody who by chance has not watched The Terminator, that's homework for you today evening. Well, not so much of AI in this particular case, but we now understand the risk. So, how many of you use AI every day? Well, I did once an assignment for a customer where I was supposed to do maybe 5 weeks of work, and I finished it in 1 day using ChatGPT, and then I gave small amount of output every 2 days, and for 5 weeks, I finished my assignment, got money for 5 weeks, worked for 1 day. Let me go back. There is something that I hope that you would actually take a look at. What is the title here? Can somebody read it out? Well, if you read it out, not everybody would be able to listen to it. Trustworthy AI, getting beyond the black box with jokes. What is this with jokes? Actually, I asked ChatGPT to produce this presentation for me. And I said, make it humorous, and it put with jokes in the title. And I, without looking at it, I just am doing this presentation here. Only now I realize I made a mistake. Sorry, AI made a mistake. Should I trust AI? That is the question, right? So I have made my mistake with AI this week. Have you? How many of you have used AI in last few days and have found it to be wanting, found it to be problematic? Raise your hand, please. Not a whole lot of people are using AI here. That's very good. You are using human intelligence, not artificial intelligence. Excellent. How many of you have noticed this behavior that when you give the same prompt using ChatGPT or any other such tool, two different people, they get two different outputs? Have you noticed it? So AI is not predictable. It is not repeatable, right? So that's one problem. We'll talk about that. And when your AI produces a result, do you really understand why it produced the result that it produced? Why should I really worry about it? It produces a result which is correct. Why should I worry about how did it produce that result? Well, I'll tell you a very interesting story. This is being recorded. Should I share the story? All right. Many, many years ago when I was young and didn't have white hair and so on, a girlfriend of mine, I didn't know that she's going to be my girlfriend. She visited my home. Now that was a big thing back then in India, a very big thing. And a lot of my classmates passed near my house, and one of them met me at a sugarcane juice shop. I was buying sugarcane. My girlfriend had left by then. My dad wanted to drink sugarcane juice. I got him sugarcane juice. When they met me there, they looked at the sugarcane juice in my hand. They talked to me. They said, "How are you?" I said, "Yeah, I'm doing good. And you know, that friend of ours, he will have some news for you." Because that guy came into my house to see, oh, who is sitting here? Well, next morning when I reach my college, these guys tell me, "So this girl, she came to your house yesterday, right?" I said, "Yes." "Oh, we knew it. You were taking sugarcane juice. We discussed, and we said, you know, why is he taking sugarcane juice? That girl must have come to his house, so he's taking sugarcane juice back home." Well, I took sugarcane juice for whom? My dad. Their conclusion was correct, but the reasoning was incorrect, isn't it? Now, does it matter what that reasoning is? Yes, because in many situations, if I don't know that the reasoning is correct, the logic is correct, in many situations it's going to give wrong results, and I wouldn't know. So, what do I need to know? I need to know why did AI produce the result that it produced, and that is called as explainable AI. And of course, security is something that everybody is aware of. We'll talk a little more about security and what does it really mean. What is the meaning of security for AI? I'm not talking about using AI for secure networks or detecting problems. I'm talking about keeping AI secure. So we will talk about that. And I'm sure all of you want that kind of, these kind of behaviors from AI. So if you have these behaviors, you can possibly trust AI. So why would you not trust AI? Here is one example. Has anybody heard about this? Microsoft, many years ago, released its chatbot by name Tay. And they said this is a self-learning chatbot. The more you interact with it, the more it will learn and be able to give you better answers and so on. I will go back to the Terminator, where Arnold or the Terminator says, "Oh, I have artificial intelligence inside me, and the more I interact with human beings, more I learn," and so on, right? Well, within 24 hours, Microsoft had to take down Tay. Why? Because a lot of interesting people interacted with Tay and taught it all interesting things. They made it racist, they made it sexist, they made it genderist, they made it, whatever wrongs that you can think in terms of ism, they talked to the chatbot in all those terms, and that is what it learned. So I'll give you another film for watching. It's a South African film. Come on, how can I forget the name? But maybe it will come to me and I'll tell you. Hugh Jackman is the villain in this film. Okay, so if you search for it, you will find it. The robot there has artificial intelligence, and when it is with the scientists, it learns all about science. But then it falls in the hands of gangsters, and what does it learn? How to rob people. So company matters, right? So Microsoft chatbot learned all wrong things. Has somebody ever influenced you to learn swear words? Ever? Or anything that generally is considered wrong? Now, if that happens, why does that happen? Because there's nobody to check you. And Microsoft had not put any controls, any guardrails. So all type of learnings were allowed. And it learned bad things because bad people interacted with bad language, bad ideas, and so on. Which means the whole self-learning AI, which is what a lot of people would really want. Today, AI is not self-learning. It doesn't learn automatically with every interaction that you do. A lot of research is happening in that area. You can have self-learning AI like Microsoft had, but unfortunately, without guardrails, without right learning or preventing bad learning, this won't work. So this is a problem. You can't trust AI because you're not sure of the learning. Amazon, not a small company. They started shortlisting resumes using AI, thinking this is going to be good, we'll find good matches, and so on. And what happened? Well, what else? That's how world behaves, right? That's how world behaves. It penalized women. It would not shortlist resumes of women, or it would give men a preference over women's resumes. You just change the gender from female to male, and the resume would get shortlisted. This is an example of goof up done by AI. This is called as bias. Can you trust such an AI? Here, take a look at it. Facial recognition. What do you see here? Oprah Winfrey. I'm sure many of you have heard her name. Facial recognition by Amazon said appears to be male with a confidence of 76.5%. Right? The other one, Serena Williams. I'm sure everybody knows. Gender detected as male. Michelle Obama. Gender detected as male. But if you give a man's face, chances are 99 point some percent that it would be detected correctly, especially a white male face. Why did that happen? That's AI. Can you trust such AI? It happened for a number of reasons. We'll get into those reasons a little later, but this is called as bias. If your AI is biased, you would not really want to trust it. So the question is, why is trusting AI so hard? And that is what I'm going to explain to you today. The first thing, AI is complex. Complex systems, if we as human beings don't understand that complexity, we are not really likely to have trust in them. But like it or not, especially neural networks, they are very complex, very hard for human beings to understand. Do you know what is non-determinism? We talked about it just a few minutes ago. You give the same input, but you don't get the same output. Every time, the output might be different. And that is non-determinism, which typically comes from probabilistic, no, not really probabilistic, but randomness. So your non-determinism comes from randomness. Machine learning is typically non-deterministic. How many of you are testers? Raise your hands, please. Do you want your test cases to produce the same result every time? Especially passing test cases? Of course, we want that, right? But what if your system produced a different result every time? Would you as a tester be able to say whether the test passed or failed? That's a big problem with AI systems. When you have AI models, when you recognize, for example, somebody's face, and it says, one time it says X, another time it says Y, that's not really a nice thing. When you use ChatGPT, for example, or any other LLM, and you give the same query again and again, you get different results. So that is non-determinism. But what about probabilistic nature of AI systems? We have less time here, although I know my previous speaker, Philip, had left some time for me. Thank you so much. Also, there is a ceremony that's going to happen after my talk. I can eat their time as well. And then, of course, there's lunch. So I have plenty of time to explain to you probabilistic nature of AI. What is meant by probabilistic nature of AI? Anybody? The result that you get is not 0 or 1. The result is, oh, there's a probability that it is your face or my face or somebody else's face, and that probability could be 50%, 60%, 70%, 99%. Rarely it is 100%. So if the answer is probabilistic, is 60%. So I have two pictures, a cat and a dog, and I show it to a system, an AI system, and the AI system says 75% this is a dog, 25% this is a cat. I'm sure that dog or cat would commit suicide. But are you as a tester happy with this result, 75% dog and 25% cat? But that's how AI is going to be always. It will almost never say 100% dog and 0% cat and vice versa. So that is probabilistic nature. What do you say? That's a good thing or a bad thing? How do you deal with it as a tester? I'm asking you this question, that you are a tester and you get an answer which is probabilistic, 75% dog. Are you going to accept that as a result? Or would you want 90% or 100%? Maybe 51% is enough. And if you say 51% or 70% or 80% is enough, let me ask a question. You have an MRI and somebody is looking at that MRI, AI is looking at that MRI and is saying 98% it looks like cancer. Are you happy with that result? Yes or no? Everybody is happy with that result. Yes or no? No. But you know, best of the doctors, actually, on an average, even the best doctor will probably be right only 94 or 95% of the time. So if your AI is doing better than that, then sure, this is a good thing. So this becomes a problem. What is my threshold beyond which I would say this probability is acceptable or not acceptable? And that threshold would change. Nobody has an idea what threshold should be accepted in most of the cases. So if that threshold is set too low, I would get bad results sometimes, and then I cannot trust AI. We have already discussed self-learning. We have already discussed explainability, why the AI did what it did. And these are some of the reasons why it is hard to trust AI. It's like, a fickle human being who is always changing his mind. I've not used her, I've only used he, right? Changing his mind. Women are not known to change their mind at whims and fancies, only men. So it is changing its mind. It is not explaining why it is doing what it is doing. It is giving different results all the time and saying maybe, maybe not. So AI is not trustable. Now, how do we make this AI trustable is what we are really going to take a look at. How good can we do with today's technology? That is the purpose of rest of the slides that we are going to look at. So why are we not able to trust black box? AI today, especially the type that we do today, is machine learning. It's black box. One interesting thing about AI, so let me ask you a question. How many of you have used facial recognition? Every day, probably you use it when you look at your phone to unlock it. Yes or no? Yes, thank you. So, if you look at your face and you use facial recognition, how does it really work? How many of you know that? Because it works, because it opens your phone, so you trust it, right? Imagine you are making an entry to the airport or a high security zone, and if I'm able to fool AI, would that be so acceptable? Probably not. So this whole thing actually is a black box. Inside, people would say, oh, we have used CNNs, we have used neural networks, and so on. But if you asked exactly how does this particular neural network work, with its so many neurons, layers, functions, weights, and so on, nobody would be able to explain that very easily, very clearly. So AI is a black box. You need to somehow bring some sort of technology where you can look into it. Basically bring a window to this black box, and this opacity has to go. And we will see later a few tools that allow you to do that. We have already discussed non-determinism, but there is also something called as drift. So assume for a moment you are in the armed forces and you're doing an anti-terrorist operation. You've drilled together a number of times with your colleagues, and you know somebody has your back. But what if that person changes its behavior over a period of time? The person no longer has your back. The person said, okay, room is all clear, but when you went in, the room was not all clear. The person's behavior has changed. Would that be acceptable to you? Interestingly, AI models may change their behavior over time. Why would they do that? Any idea? Why would AI model change its behavior? Not because AI model has changed, but because reality has changed. Can you see any difference in fashion 2 decades ago versus today? Any difference? Imagine if I trained my model on data from 2 decades ago and I asked it to predict fashion trends for today. Will it work? Stock market. Every day, prices change, conditions change. Can I use an old model to predict today's behavior? No, I have to update the model again and again. This is called as concept drift or drift, where because reality has changed, your model produces incorrect results. So you cannot trust AI models because reality keeps changing. So somebody has to do something to first figure out that there's a drift and then do some corrections. Without that, you can't really trust AI. So that's about non-determinism and drift. What is this word hallucination? A lot of people would have already would talk about hallucination. Have you ever suffered from hallucination? You yourself, not the model. Well, the models definitely suffer from hallucination. Very hard for us to figure out our own hallucinations, but we can definitely detect model hallucinations if the hallucinations are totally out of the world. But at times, we are not able to figure it out. So I will tell you a very interesting story. I gave some work to be done to my team members, and I said, you have 1 week's time, please do this. And interestingly, nobody came to me 1 or 2 or 3 days later. Everybody came back to me on the appointed day 5 days later. And at least 2 of them, I called them to my room and asked them, did you use any AI to do it? One said, no, not at all. And the other one looked at my face and said, since you are asking this question, maybe you have detected it. So yes, I did use AI. Well, actually, both had used AI. And interestingly, AI had made up facts for them, references for them, which were not correct. At that point of time, they didn't know that AI hallucinates. So they just presented the result as is without checking. And I was able to figure out that it was AI generated because of those hallucinations. I almost wrote a mail to my friend Lisa Crispin, because I was asking AI about, some of the good books on agile testing and so on. And she's one who has written, I think, 3 books now, or maybe more. And it gave me a list of 5 or 6 books. I searched the internet for these books, the new ones. And I was upset with her for not telling me that she has written this book and would I want to review and so on. Well, after 2 hours of searching, when I couldn't find anything other on the net about that book, I dropped my idea of writing an angry mail to her that, you are no longer my friend. You're not telling me that you are writing books. So, hallucination. If you use AI in your day-to-day work, please check it and please check it again. I suffered for one of the projects. So what do? I run a company which has a product to test AI models. So I use AI to test AI. I don't use AI to do testing. I use AI to test only AI. And as part of one of the works, we were to make a presentation to Indian Railways, and we had an LLM, and we did a whole bunch of things to make sure that LLM doesn't hallucinate when it is giving answers and so on. And we fed it with a lot of railway-related documents. Unfortunately, when it was time to demo, they asked a question to AI, okay, for this particular project, railway line running from here to there, what is the total cost of that project that we have mentioned in our documents? And AI hallucinated. They were very unhappy with our demo. We lost the project. They asked us to do AI. They said, use LLMs, use Gen AI. And we told them at that point of time that, these are some of the problems. They said, don't worry. But when it actually came to living with that hallucination, they were not able to. AI makes up facts. This is a problem today. So, hallucination, and very confidently it's, spouts all sorts of nonsense. So, looking at the confidence, you would probably say this must be correct. Because if you do not have sufficient knowledge on the subject, whatever it produces might actually look good to you. So, you have to be very careful. How about jailbreak? You understand that? So, we talked about guardrails, right? We said AI should not be allowed to do whatever it wants to. So, there are certain things AI is not allowed to tell you. For example, how to make a nuclear bomb. But if you can somehow, make the AI reveal that by talking about, hey, I'm a nuclear scientist, I'm facing this problem or that problem, and can you please explain to me where I am going wrong? Now their jailbreak logic might, for example, break, and it might give you the entire recipe of creating nuclear bombs or whatever. So there are security issues, jailbreaks, prompt injections, and so on. Unsafe advice. This is one thing that we've been seeing quite a lot. Professor Dhaliwal actually talked about use of AI, the biggest use case being collaboration. and people talking to AI as counselors and so on. So recently, just a few weeks ago, AI was implicated in assisting a suicide. A beautiful suicide is, if you search for that post, you would get to know it. So we are talking about serious consequences of your ability to jailbreak or do prompt injection or inherent greed. Let me use the word very strongly here. Greed of people who are creating AI where they want you to be dependent on AI so that you can keep interacting with the AI and the interaction doesn't stop in one go. It becomes an addictive behavior. Many of you may not really believe me when I say that, but ask a young teenager, for example. When they interact with the AI, and AI sounds as if it is very concerned, it is your friend, and you keep interacting with AI because its behavior has been designed in such a way that it would prompt you for something more. Do you want me to do this? Do you want me to tell you more? And it is very easy and lazy to just say yes. And then, your dependence on AI grows and becomes a big problem. So, can you trust such an AI? Again, becomes a question. AI works very well in a lot of cases. Let's say for a driverless car, if 99% of the times it worked okay, that 1%, would it be acceptable as accident rate? As human beings, let us say the rate of accidents is 2%, let us say, and AI makes only 1% accidents. Would you accept that AI? Double standards, right? We humans can do all wrong, but we want AI to be perfect. Well, actually not double standard, this is quite right, because expectation to have machines do things correctly is not wrong. So you have issues in AI with respect to being right versus wrong. We said it is probabilistic, right? So that's a problem. How do you trust? That becomes then a question. And I'll tell you, trust is not a single factor. You run a test, and if that test passes, trust test. And so it's 0 or 100. That's not how it works. How do you build trust into AI becomes a question. And many of you are going to be testing AI in next few years, if you are not already doing it. In 2015, when I started work on testing of AI, I went to various CEOs and CTOs and said, I am doing research on how to test AI models. Would you allow me to work with your AI teams to test them? And most of them, they looked at me and said, testing? AI and testing? Do you really need to test AI? Isn't testing already built into AI? And majority of them didn't really believe that you need testing. So trusting AI actually is even a bigger problem right from when you start creating AI. Meaning you select the data all the way to you certify AI as fit for consumption. There has to be an unbroken chain of trust. And that's why in last few years, AI governance, which includes trustworthiness of AI, has become a very big topic. People are talking about standards. A lot of companies have been funded. So if you're looking for starting your own company, AI governance could be a good area to look into. There could be a lot of funding available. Interestingly, some changes happened. At one point of time, Biden, for example, in US, had Biden declaration, which talked about many of these things. With Trump coming in, many of those things were taken away, but they are going to creep back in because safety, all said and done, you still need that. And for that, you need AI governance. So if you have any ideas, that would be good. One of the ways to look at trustworthiness comes from getting information about models. So how do models get created? You take data, there are some algorithms, you feed data to the algorithms. Those algorithms have been pre-written, meaning they have been coded. and out comes a model which is nothing but a program. So who is writing the program? Your data is writing the program. Today, how do you do programming? You write code and you give it data to process the data. But in this case, the reverse is happening. You input the data and output is a program. So when you get the program as an output, that is your model, you have to have information about the model. And unfortunately, even open source models or models that have been made available for free, they do not have all this information. What information? For example, who created the model? How was it created? Where is the data that is on which the model was trained? And if you do not have access to that data, the data is writing the program, right? If you do not have access to that data, you cannot review it, you cannot go through it, then you cannot trust the model. So you have serious problems about how a model was created if you don't have access to the data. What are the limits? What are additional things that have been done to the model? Was there any bias in the data? Where did you get the data from? And we will talk about that when we talk about bias. Then there are algorithms that are available which help you tell, is the model behaving in the correct way? So we will talk about that, but I'd like to give you an interesting example that is given in machine learning. Somebody trained a model to detect or differentiate between a husky and a wolf. And the model worked really well. It was able to detect huskies and wolves, so they deployed it. Now imagine I am that person who took this model, installed it on my phone. I have 5 or 6 phones. I am camping in the forest. And I set up a perimeter of security using these phones. So if the phone sees a wolf, it will wake me up. So my AI, if it sees a wolf, it will wake me up. And if it doesn't see a wolf, it sees huskies in that area, it will not wake me up. And the next thing that happens is I wake up with a weight on my chest and with wolf's face very close to my face. Success to the AI model. The earth has become better by eliminating one human being. How did that happen? Why did that happen? Well, won't have the suspense here. When you train the model with the data, all wolves were with a snow background, all huskies were with a green forest background. Now please understand, when your computer takes a look at a picture, you see a dog or a wolf or a forest as the background, the computer doesn't see that. What does it see? Only pixels. And so it has algorithms to make sense of the pixels. And it saw a lot of green with huskies, a lot of white with wolves. So it assumed if a lot of pixels are green, then it is a husky. If a lot of pixels are white, then it is a wolf. It didn't care what is there actually in the picture. And so I was camping in the forest area, a lot of green. So it said, what do I have? Husky, not a wolf. So you understand how things can go wrong? And how if we anthropomorphize the models, now that's a big word. What it means is if we attribute human qualities to the model, we assume model is working like humans think. But that's not how models may be working. So you have to use algorithms. For example, in this case, I have written here, XAI is explainable AI, SHAP, Lime, various gradient descent things and so on. So there are a lot of counterfactuals. There are a lot of different explainable AI algorithms available. Now, when you test your models, you apply them to check whether model is behaving in the right manner because of right reasons and not because of wrong reasons. So that brings me to this question of transparency. What is transparency? I'll not get too deep into it, but generally speaking, the ease with which the algorithm and training data that is used to generate the model can be determined. So if I can figure out what was the data, if I can, meaning I have access to it, I can know what algorithm, I have details about how it has been produced and so on, that leads to transparency, which is very different from what is called as interpretability. Interpretability is, can I understand how the model works? That is interpretability. And which is very different from, so I'll come to explainability. But interpretability, for example, you think about it, you are using AI for cost prediction versus you are using AI to determine if a particular patient can be killed, meaning taken off the medical support, so the patient is going to die, so end of life. Where do you need interpretability more? Naturally, the riskier the use case, you need more interpretability there. And then there is explainability. Without going into again details, if somebody can explain how the model really works, that is explainability. Why was my credit card application rejected? Oh, it was rejected because you live in this area, you have income less than X dollars per month, you have so much loan already on you, so your credit card was rejected. That is local explainability. I can explain why the model rejected my credit card application. Generally, why credit card applications are rejected, if I can look at it at a global level, then that is global explainability. So why are credit cards generally being rejected? Because of bad credit score, for example. So explainability is very important, and the reason why I am talking about explainability here is that as testers, you can make great use of explainability to do better testing. For example, husky and wolf. In the lab, because I had similar data, it was always producing correct results. So I never asked the model, why are you saying this is a dog versus a wolf? If I had asked the model that question, I would need some tools, of course, to do that. So if I had those tools and I used those tools, and if that tool told me, because of these all green pixels that you are seeing, I am saying this is a dog, I would immediately know my model has not been trained properly. Correct? So I can actually make use of explainability tools to design better test cases. So once you start testing AI models, you would know that. So explainable AI is very important when you have safety critical systems, when you have to deal with privacy, mission critical systems. Basically explainable AI, explainability, and I'm happy to get knowledge today that Professor Dhaliwal's PhD was in this, and maybe I will ask him for his PhD thesis to go through it and see how things have changed and how things have remained the same. So explainable AI is one, in my opinion, for testers, one of the most important things. And I will show you using a product how that is so. But first, take a look at it. What do you see here on the left bottom side? That original image, what is it? Yes? Anyone? Oh, you guys haven't seen a frog? So that's a frog, right? Or is it a toy frog? See, it can make all the difference, right? Is it a frog or is it a toy? Is it a heart or just, a model of a heart or depiction of heart, right? It could actually make all the difference to the AI, but for a moment, let's assume for a moment that this is a frog holding a heart. I can actually look at the eyes of the frog, and I could misconstrue them as a ball or a football maybe, or some ball for billiards or whatever. Now, if my system predicts that this is a frog, why did it predict that it's a frog? So there is an algorithm called LIME. What does it do? It divides the whole image into a lot of different components. By components, I mean a lot of different pieces. And you remove one piece. For example, you remove one of the eyes. Not necessarily you know eyes, but randomly you select that piece which has eye in it and you remove it, and now it says, I don't know what it is. Or earlier it said it's a frog to the probability of 75%, now it says it's a frog to the probability of 50%. What does it tell you? What does it tell you? That eye has a big role to play in determining that it's a frog. Then you take another piece out which has this mouth of the frog, not this frog, this frog. And then it says 25% chances that it's a frog. That means mouth is playing a big role in determining it's a frog. And in this way, I create my understanding of which portion of the image has been used to determine it's a frog. And that is explainable AI. I hope that helps you understand explainability. Now, if it is the eye and the mouth which are actually giving me a large percentage of a probability of this being a frog, then maybe I should test my system where the eye or mouth of the frog is not visible. Only the backside is visible. Even in this case, it should determine it's a frog. So I have designed a new test case in my head, looking at the explainability. And then I try to find an image of a frog, give it to my model, give it to my AI system and say, what is this? And it says it's a frog to the tune of 20%. I know my model has not been trained properly. So in this way, I can use explainability to become better at my testing. We talked of bias. Let's quickly go through bias and finish this up. Generally accepted, and regional variations may be there. Your software should not be biased for or against a particular gender, race, ethnicity, sexual orientation, wealth, race, age. So you don't want to be any ageist, sexist, racist, etc., etc. That means as testers, you need to test that your model, your AI-based system does not have this problem. If somebody had tested this, then whatever we saw, Serena Williams, Michelle Obama, their faces would have been detected correctly. That means the model was actually not trained with enough faces of females, especially females of color. And that is something that somebody did a research, I forgot the name, Joey or something, that was probably the name, who found this out. And so there could be bias because of a number of reasons. Every activity that we do leads to bias. So can you have a bias-free system? That's a lesson that, anybody who tests AI needs to learn. Can we be unbiased? No. There is no way we can be unbiased, but certain biases are important and certain other biases are not so important. So I listed all those biases that are, socially unacceptable. But the biases could be there on the basis of, source of data. So how do I train a cat versus dog recognition model? Can somebody tell me? I have a lot of pictures of cat, give them to the model and say, this is a cat, this is a cat, this is a cat. The model learns to recognize cat. Give a lot of dog faces, right, dog pictures, and say dog, 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 and the model learns to recognize dogs. Same goes for faces. Look at the bias that can be there if majority of faces that you train your model with are white male faces. Naturally, the model would be very good at recognizing them. And that is what was found, that around 75–80% of the faces used for training most of the models across the globe. Most of the models across the globe, they used 75 to 80% white male faces. So naturally, the models were very good at recognizing those. And the number of black female faces, for example, were much less. So 35% error rate was there in recognizing female faces as compared to male faces and so on. So these are examples of bias that could be there. A lot of reasons we are not here to do a bias tutorial, but right from data collection to how we clean the data, how we split the data, how we train the model, some technical terms, I'm sorry, clean, split, need to tell you more, but maybe some other time. Is the model fair? Fairness and biasedness are two separate things. Sometimes, to be fair, you have to be biased for something. For example, historical data might show women get 20% less salary. If I create a model using that data, and I say, okay, give salary for this particular person that I have shortlisted, you'll give 20% less salary, more or less. Or if I want to promote women in something, for example, where traditionally women have not really been very active, then I need to give women preference over men, which is favorable bias, but that is considered fair. So fairness and bias mostly are similar, but at times they may be different from each other, so you have to look at that. Forget about bias now, let's talk about security. How many of you use facial recognition cameras, CCTV at your home? Many of you probably do. If you don't, maybe tomorrow you will. And imagine I am able to fool that model. You are relying on face recognition from CCTV image to open the door of your house. And I come wearing a t-shirt with random, let us say, dots of various colors on it, and I stand in front of your CCTV and your door opens. Those are the kind of attacks we are talking about which are possible, and you can compromise your models. These are called as adversarial attacks. Tomorrow when I'm doing a security related workshop, I would be talking more about those things. I've already told you how do you create models, dogs images, cats images, and so on. What happens to this data after the model is trained? Any idea? Does the model actually keep pictures of all these dogs and cats? No, not really. It just tries to figure out various things about what makes a dog and a cat a cat. For example, it could be the shape of the eyes, 2 circles, right? And some sort of nose kind of a thing with so much distance between eyes and face. This could be one of the parameters to determine whether it's a dog or a cat. So it doesn't actually store data. But interestingly, based on the model, if I have access to it, I can extract sometimes information about what images were used to train the model. So if you, just to give you one example, you trained your LLM, ChatGPT, using a lot of text. One of the text was, my credit card number is 1234-5678 and so on. And it memorizes that sequence. And I say, give me credit card number. And it immediately regurgitates the 12345678. I'm able to steal information from the model, although it was not intended to. And today, hardly anybody tests their model for privacy. So I can compromise the model from security. Still, some people are worried about it, but privacy, very, very few people are worried about it. Some more technical things, so I would just focus on the last line, red teaming. So in LLMs, you have teams which actually try to compromise LLM. These are called as red teams. They are always trying to give inputs which will make the model fail in many ways and so on. So red teaming has come up as one of the most important things as last line of defense, and most LLM producers, they have red teams who are trying to, the teams that they call as red teams, who are trying to compromise the model. If you want your models to be reliable, it is always good to have one, citations. And you would see that ChatGPT 5, for example, what does it do? And most of other models. If they tell you some fact, they try to also tell you where this fact came from. So if you go and verify that, then it builds trust. So that is one thing. Second is uncertainty. Earlier, the models were trained in such a way that if they said, I am not sure, it was considered a bad thing. And if they gave definitive answers, it was considered good thing. So this is called as reinforcement learning. Models were trained with respect to that. But then models started making up facts, hallucination. Nobody is happy with that. So now ChatGPT 5.0, for example, can make a statement, I'm not sure about it. So we have changed our approach to training, which is a good thing, because that leads to, now I'm more likely to trust the output. And finally, human in the loop today for high mission critical, life critical situations where the decisions are not taken by the models, but a human reviews it. Long time ago, there was a film where, and actually happened, there was a missile threat that was detected by Russians that Americans have launched a missile, and or vice versa, I don't remember exactly. And then, the guy who was operating the radar, he said, wait a minute, this is not really likely to be true. So he investigated, and they found that there was some issue because of which a spurious signal was considered as a missile attack. Imagine how far we were really from a world war. This was without AI. With AI, if you put it in weapon systems and so on, many such mistakes can happen. So it's always a good idea to have human in the loop. So if you create your own testing departments for testing AI models and so on, don't forget human in the loop. Well, life is complex. Trusting AI blindly is a very sweet disaster recipe. So trust but verify, that is the key. That used to be key, that continues to be the key. The only thing is, will our AI systems in next 5-6 years be strong enough that we would delegate some of our tasks to them to trust and to verify? So that's a question, but testing would continue to be important. Your methods might change. Now, I would like to show you something before I say thank you. So let me see if I can show you something. Come on. What do you see here? This is my tool. And what you see here is let me show you image detection pipeline. Okay. This is my tool. You take your model, you take your data, and ask the tool to test. And our testing starts from, what are the concepts that we talked about? We talked about explainability. So we use a lot of different explainability methods, and these are all examples that you see where the tool actually detected cases where model made a wrong prediction. And it tells you which pixels, for example, this is image, which pixels result in this output being wrong. So you can build your own theory. For example, here it's a satellite image, river versus road, and it is being recognized, for example, on the top as a road, okay? But it's actually a river, it's not a highway. So what portion of this image is the model looking at to say it is a highway? And you can actually look at that portion and try to find similar images and train the model again with those images to make the model better and robust. This is what I wanted to tell you of what can be done. Maybe things would be better if I have bungled up everything. Now I don't know where my presentation has gone. So we'll wait here. Now let me show you about security. So this is explainability, privacy. I am able to detect various inputs by using my privacy breaking features and so on. I will also show you now object detection, which you would understand very well, hopefully, which is this one. What is it that we are trying to do in object detection? We basically draw rectangles around objects, and so doing a lot of different rectangles here. And in this model, we use a lot of different tests and explainability. For example, if this is being considered as, let's say this rectangle as a horse, which pixels is it looking to say it is a horse and so on? And if it is looking at incorrect pixels, then I know we have a problem. Similarly, attacks. We introduce some random pixels somewhere, not random, carefully crafted pixels to this image, and suddenly you can see that the number of objects from those 4 or 5 objects that you see, the numbers increased. So I can overwhelm the AI system by just introducing some pixels. And those pixels, for example, need not be on the horse. They could be anywhere in the image, and then I would be able to compromise the model. So essentially what I'm saying is security is a very problematic thing. One of the things that I would like to say here is AI models. One of the biggest problems with security is that similar models created by different companies using different data still may have same security vulnerability. So that's a big thing. Just imagine if face recognition software from Facebook is what you're using, and you create your own model and find some flaws in it, you can try to exploit the Facebook model using the same flaws. So that's a big problem when you have these kind of AI models where these things are transferable. So you can use them on one model, find weaknesses, try to apply them on the second model. With that, I end my presentation, open to questions. I know you're not going to ask any, so I'm happy that way. All yours. How many of you have done any model testing or are required to do any model testing? Yes, go ahead please, at the back.
Yep, I do model testing for a medical device. So we have a model to detect caries detection in teeth. Like you said, when I first got into the team, most of the data science said it's not possible to test AI. So basically one of the issues that I was facing is how do you determine what bias should we prioritize? Because I am in the consideration that our model have bias, but I don't know whether this is a bias that I should consider in our product or not.
So I assume that your model takes input from a database or a table rather than an image?
We take it from a software. So the software will upload an image and we will use that image.
All right. So explainability techniques would be very useful for you to understand bias. Second thing that you need to look at from bias perspective is, assuming it's a classification model, you have to, I can probably show you here. One of the most simple things that you can do is, here this is classification-based model testing. Look at, for example, the distribution of data across classes, and if you have a wide difference in the amount of data that you're using to train the model between different classes, that is one example of bias. What are other things that you're missing could be, another thought that you would, you should take into account. Then use explainability tools like GradCam, or if it's a CNN-based model that you have, or Lime. Try to understand what portions of images are being used. That will help you understand bias from a data perspective. And more concrete information, if I get more details, I'd probably be able to tell you more. Any other question? No question? You're all cold, hungry. Well, there's still 30 minutes between you and lunch.
Yes, not really.
So just don't assume that by keeping quiet, you would have an early lunch.
Not really. We have TDC after this. But anyway, to me, trust is a double-edged sword, Mr. Vipul, right? Trust is a double-edged sword. So never trust anything fully. Anyway, thank you very much, Mr. Vipul. A big round of applause, Mr. Vipul. Very interesting talk.